Just take a look around you for a second. Seriously. Your laptop, that coffee mug, the chair you're sitting in, almost everything you see probably crossed an ocean to get to you. So in this explainer, we're going to meet the absolute giants that make all of that possible.
You know, from the phone in your pocket to the sneakers on your feet, chances are it spent some serious time on a massive container ship. But the real magic, the part that's just amazing to watch, happens right at the port. So how does a 40-ton steel box get from way up there on that ship down onto solid ground?
Well, a huge part of the answer is this incredible machine right here. Meet the ship-to-shore crane. It's really the unsung hero of the port, the absolute linchpin of a global supply chain that moves trillions of dollars in goods around our planet every single year. Okay, so what is it really? At its core, an STS crane has one job and one job only: to lift these massive shipping containers, and we're talking up to 40 tons a pop, off a ship and place them on the dock. Or, of course, the other way around. And it has to do it with unbelievable speed and pinpoint precision, over and over and over again. So how in the world does this steel behemoth actually work? To really get it, we need to break it down. I want you to think of it like a giant mechanical creature, where every single part has a super critical role to play.
So, the foundation of this whole thing is the gantry. Think of it as the crane's legs and its skeleton. This massive steel frame is what gives the crane its incredible height and stability. And it actually sits on rails, which lets it move horizontally along the entire length of the dock, positioning itself perfectly over the ship's cargo holds.
And reaching way out from that gantry is the boom. This is the crane's enormous arm. It stretches out over the water, right over the ship's deck. And you see how it's hinged? That's so it can be lifted up and out of the way, which allows these massive ships to safely dock and then depart without hitting anything. Pretty smart.
Now, zipping back and forth along that boom is the trolley. It's the real workhorse, the part that carries the container all the way from the ship to the shore. And often, you'll find the operator's cabin mounted right on it, giving them literally the best seat in the house for all the action below.
And hanging down from that trolley is maybe the most specialized part of all, the spreader. So if the boom is the arm, then the spreader is the hand. But how does this hand actually grab a multi-ton steel box? Well, the way it works is actually surprisingly clever. Okay, so the operator lowers the spreader until it sits right on top of the container. Then, these four sort of mechanical fingers, called twist locks, rotate, and they lock into special slots on the four corners of the container. A monitoring system confirms that it has a secure lock, and only then can the lift actually begin. It's an incredibly robust and, more importantly, safe system.
Of course, none of this would happen without the brains and the brawn. The operator, that's the brains, sits up there in the control cabin, using joysticks and monitors for incredible precision. But the brawn, the raw lifting power, that all comes from the hoist mechanism, a super complex system of powerful electric motors, gearboxes, and thick steel cables that do all the heavy lifting.
All right, so we've seen all the parts. We've broken down the anatomy. Now, let's put it all in motion. We're going to follow the short but absolutely crucial journey of a single container as it moves from the ship to the shore. You know, it's like a beautifully choreographed four-step dance. Step 1, positioning. The entire crane glides along the dock to line up with the right cargo bay. Step 2, securing. The trolley moves the spreader out, lowers it down, and locks right onto the container. Step 3, lift and transfer. The hoist yanks the container high into the air, and the trolley zips back over land. And finally, Step 4, placement. The container is gently lowered onto a waiting truck or one of those cool automated guided vehicles. Get this. This entire cycle can take less than a minute before it just repeats hundreds and hundreds of times a day. And it's really important to clear up a common misconception here. You might be imagining some kind of big pit or sorting area where the containers go, but that's not how it works at all. These cranes are designed for a seamless transfer. The container is lifted from the ship and it's placed directly onto its next ride on the dock. In this game, efficiency is absolutely everything.
Now, when you have a machine this large, moving this much weight, pretty much 24/7, there is zero room for error. I mean, downtime isn't just an inconvenience. It can literally halt millions of dollars in trade. And that's why the science of maintenance is so unbelievably critical.
The maintenance schedule for these things is just relentless. Every single day, crews perform visual checks on the structure and the cables, and they test every safety feature. But the annual tests, well, those are the real deep dives. They use methods like ultrasound. It's called non-destructive testing to find hidden cracks in the steel. And they even do full load tests, lifting a maximum weight block just to prove the crane is still up to the task. It's this constant vigilance that ensures both safety and, of course, that all-important efficiency.
You know, these cranes are a global phenomenon, but they are not all created equal. By looking at their size and even who builds them, we can actually see a much larger story about the incredible scale of modern trade.
So a crane's size is directly tied to the ships it's built to service. For decades, what they called Panamax cranes were the standard. They were big enough for any ship that could fit through the Panama Canal. But as ships got wider, the cranes had to get bigger too. Today, you see these massive post-Panamax and super post-Panamax cranes towering over docks, with this incredible reach needed to service the new generation of behemoth container ships.
And the companies that build these engineering marvels are global giants themselves. And just look at this list. While China's ZPMC is a totally dominant force, major players come from all over the world: Finland, Japan, South Korea, Switzerland. It's a perfect illustration of just how interconnected global logistics really is. Even the machines that move the goods are part of their own global supply chain.
And this all brings us to a final, really fascinating question. For decades, it's basically been an arms race. The ships get bigger, and so the cranes have to get bigger to keep up. So as we continue to push the boundaries of engineering even further, what's next for these giants on the shore? Are they just going to get taller, faster, or maybe they'll become fully autonomous and smarter? That, right there, is the next chapter in the story of global trade.